Okay, hi everyone. We're doing a right triangle trigonometry today, specifically with 30, 60, 90 triangles. And we're going to throw in the special 30, 60, 90, and 45. Let's write that. We're going to do 30. Let's do 45 next, 60, and we're going to do some special 90-degree triangles today. And you're going to have to know this by heart. It's going to be used in not only this class, but in calculus. And we're going to derive these triangles, and we're going to see why are they important for us to know. And I feel like it's easier to know how we come up with it rather than just straight memorization. But if you can memorize it, all the better. So first thing, I'm going to show you guys the special triangle of 30, 60, 90 triangles. Okay, so this is what 30, 60, 90 triangle looks like. We have one short side next to the 60-degree angle, one long side next to our 30-degree angle, and the hypotenuse. Okay, so we'll call it short, just so you guys can see it. This is long, and this is hypotenuse. So no matter how I spin this triangle, even if I draw it in this arrangement here, and if I tell you the 60, remember, 60 is a fatter angle than 30. So it's always going to be obvious that one's a fatter angle and one's a skinnier angle. So the fatter angle, this would be next to the 60, and the skinnier angle would be here. So this is our short side, our long side, and this is our hypotenuse. So be careful how we spin this around. Now, all 30, 60, 90 triangles always have this relationship. And the relationship is actually pretty simple. The relationship is that let me use numbers first. If I tell you the short side is 3, then the long side must be always, the hypotenuse side is always double. That'll be 6. So times 2. And the long side will always be times square root of 3. So this will be 3 square root of 3. That is always the case. Let me draw another example quickly, just so that we can see it. If I say this is a 60-degree triangle, and that's a right triangle, the third side must be 30. There's no other choice, because we always have 180 degrees inside all triangles. Now, if I give you a side, let's say this is 5, then the hypotenuse is always double to be 10, and the third side is always square root of 3 that. Always going to be true. Always double to get to the hypotenuse, and square root of 3 to get to the long side. Well, why is that useful to us? Well, it's going to help us realize that all 30, 60, 90 triangles hold a certain ratio. And the ratio is going to be easy for us to derive in just a moment. Now, let's come up with, how do we come up with a 30, 60, 90 triangle? Well, let's go through a basic geometry triangle, which is called a regular triangle. And we'll say this is 60, 60, 60. Regular meaning all the sides and angles are the same. If I give you a side and call this 2, 2, and 2, okay, that's a regular triangle. I'm going to go ahead and cut this triangle in half. A perpendicular bisector, you could say. It's going to be a right angle. Hey, if I cut the angle in half, we're left with 30, 60, 90. That's the triangle we just saw. Now, because I cut the side in half also, this side is no longer 2. It is now just 1. So it's always half of the hypotenuse. Take a look. It's always half of the hypotenuse. The short side is half of the hypotenuse because I just cut it in half. And the third side, if I use Pythagorean theorem, 1 squared plus b squared equals to 2 squared. Okay, it's going to be 1 plus b squared is equal to 4. B squared is equal to 3. B is equal to the square root of 3. We can do that for these other sides. 5 squared plus b squared is equal to 100. So 10 squared, which is 100. That's b squared is equal to 75, because 25 on both sides. And then the square root of 75 is really 5 times 5 times 3. We're left with 5 square root of 3. Hey, look, a square root of 3 is still there over here with 6's. So it's 3 squared plus b squared equals to 6 squared. That's 9 and 36. And we subtract that, b squared is equal to 27. b is equal to 3 times 3 times 3. That's 3 square root of 3. Square root of 3. We always end up by when we relate the short side to the long side by square root of 3. Okay. So the 30, 60, 90 triangle, since it's always going to be this ratio of short to hypotenuse is double and short to long is square root of 3, it's going to be helpful to us because let's go ahead and give us an example of what happens when I ask you, what is the sine of 30 degrees? Well, if I look at this triangle here, look at the triangle, let's draw the basic one again. Here is my 30-degree triangle. We know it's 30, this must be 60, and 1, 2, square root of 3. I'm going to show you guys a little trick here. The sine of 30 refers to opposite over, sine is opposite over hypotenuse. So my opposite is 1, hypotenuse is 2. Now, is this true for the sine of 30 all the time? Turns out it is. Look back over here at this triangle, please. I want you to look at the sine of 30. Sine is, that's my 30. It's opposite over hypotenuse. Wouldn't that be 3 over 6? Isn't that the same as 1/2? Look at the triangle to our right. Looking at 30 degrees, the opposite of 30 is 5. Hypotenuse is 10. That's also 1/2. So what's sine, cosine, tangent? They really compare the two sides, and this is always true for sine. The opposite over the hypotenuse for 30-degree triangles will always be 1/2. 1/2. So if I draw you an angle here and draw 30 degrees, here's 30 degrees. What you do is you follow up by drawing the right triangle. Do we know the sides of a 30-degree triangle? 30, 60, 90? We do. 1, 2, square root of 3. Look how fast that was when we drew that triangle. If I ask you the sine of 30, opposite over hypotenuse. If I ask you a follow-up question, what if I ask you, what is the cosine of 30 degrees? Cosine is adjacent over hypotenuse. The tangent of 30 is opposite, which is 1, over adjacent, which is square root of 3. Which can be rewritten as square root of 3 over 3. So the big takeaway is this. If I can draw my triangle with the 3 sides, sine, cosine, tangent, got it, fast. So what if the angle isn't a nice 30? Well, here is something kind of cool. If I draw the angle over here at 150 degrees, 150 degrees is an angle coming off to my left, a full 150. But what's the reference angle here? What's the angle that's left over? Isn't that also 30? Well, if I see it 30 degrees, it's a right triangle. We know it's 1, 2, square root of 3. Again, the one side is always the shortest side. 30 degrees, my shortest angle, that means the opposite side is my shortest side. Hypotenuse is always double in a 30, 60, 90 triangle. Now, here is one issue that we have to get straight. 150, please look at it. My sides are 1, 2, square root of 3. But if I drew this on a regular x and y plane, would any of these values be negative? So we went up to get to 1, but we went left to get to square root of 3. So be careful, we have a negative square root of 3 here. So the sine of 150 will be opposite. Here's my opposite of 30 degrees. It's only 1 over 2. The cosine of 150 is going to be negative square root of 3 over 2 because it's my adjacent over hypotenuse. And the tangent of 150 is negative 1 over square root of 3, rewritten as negative square root of 3 over 3. To give ourselves more space, I'm going to draw this unit circle on the bottom. For the angle now, it's going to be 210 degrees down here. 210 degrees. So what would the reference angle be for 210? What angle would it take me to get back to horizontal? That would be 30. Hey, doesn't that give me another 30, 60, 90 triangle? So let's fill out the 3 sides. We always draw the angle first. Then if it's a common special triangle for us, 30, 60, 90, or 45, we're going to fill out the sides. That's going to be 1, 2, square root of 3. Any of these sides will be negative. We went left and down, left and down. Left is negative, down is also negative. Hypotenuse will always be an angel, and it'll always be positive. Hypotenuse is always positive for us. Okay, looking at the sine of 210. This is going to be opposite, which is negative 1 of my reference angle, negative 1 over 2. Cosine is of 210 is adjacent. See adjacent square root of 3? So it's a negative square root of 3 over 2. And my tangent of 210 is negative 1 over negative square root of 3. Negative become a positive 1 over square root of 3. Rewriting this as square root of 3 over 3. We're going to do one more here. And you can probably guess that's going to be in quadrant 4. Quadrant 4. The angle, what would be a 30-degree angle? This would be 360 minus 30 would give me 330 degrees in quadrant 4. 30 degrees. Oh, I've seen 30-degree triangles before. The sides are 1, 2, square root of 3. 1, 2, square root of 3. So I made a mistake here. 1, 2, square root of 3. I was thinking about something else on the side. But remember, 2 is the hypotenuse, and square root of 3 is the long side. Okay, so 2 is always my bigger side. 2 is bigger than square root of 3. Now, knowing quadrant 3, we went negative, so make sure you write negative in front of that 1. Okay? It's a negative 1. All right, let's do our sine, cosine, tangent. Sine of 330 is opposite, which is 1, and hypotenuse is 2. Sine, so cosine 330 is square root of 3 over 2, because it's my adjacent to angle 30. And tangent 330 is opposite over hypotenuse, which is negative square root of 3 over 3. So this brings us back to when we're talking about our, so we see some characteristics that we're going to draw right now. First, we have a way of seeing when sine and cosine will be positive or negative. So right now, looking here, sine is positive, cosine is positive, tangent is positive. In quadrant 2, only sine is positive, but everyone else is negative. In quadrant 3, only tangent is positive, everyone else is negative. So in essence, everyone takes a turn to be positive. In quadrant 4, cosine is positive, everyone else is negative. So some things that we need to be able to take away is that you can do these actually really quickly if you know in what quadrant what is going to be negative. And there's a way of doing that. It's all students take calculus. It's just this way for us to memorize what's going to be positive, what's going to be negative. In quadrant 1, everyone is positive. Sine is going to be positive. Cosine is positive. Tangent is positive. And you can see that everyone is positive. Now, besides just memorizing it, can I show you guys a practical way of seeing it? In quadrant 1, doesn't your x values and your y values both go in a positive direction? Right? If I take out any point here, all points in quadrant 1 have a positive x and y value. So both sine and cosine are going to be positive. Just as a reminder, cosine is your x value and sine is your y value. Whoops, let's use theta. Cosine is your x value and sine is your y value. That's our general idea. So in quadrant 1, sine, cosine, and tangent, everyone is positive. In quadrant 2, who is the only value that's positive? Sine is. Now let's look at y. In quadrant 2, our x's are negative. That means our cosine's negative. That's our x value, remember? Cosine is our negative value. But our sine goes up. So sine is our y value, and that is still positive. In quadrant 3, go ahead and make a guess. Quadrant 3, we went left and down. Okay, whoops, let me fill this out. In quadrant 2, only sine is positive, but cosine and tangent are both negative. This is a fast way for us to double check. Did I make sure I get the signs correct? In quadrant 3, I see I went left and down. So not only is sine negative because I went down, but cosine is also negative. But for tangent, that's a negative divided by negative, being a positive. So tangent is positive. So sine is negative, cosine is negative, but tangent is positive. In quadrant 4, we went right in the x direction, which is a positive direction. Is x sine or cosine? Is x sine or cosine? X is cosine. So my cosine is positive, but my sine and my tangent are both negative. So please look here. Every quadrant has its own sine, cosine, and tangent that is positive. First, they're all positive in quadrant 1. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. Everyone took a turn. And a fast way for you to memorize that is all students take calculus. Everyone's positive, only sine is positive, only tangent is positive, and only cosine is positive. So if I ask you this follow-up question, what is the sine of 150 degrees? Whoops, we did that one already. What's the sine of 244 degrees? Positive or negative? Would this be greater than 0 or less than 0? Positive or negative? Positive or negative? Where is 240 degrees in? That's in quadrant 3. And all students take calculus. Only tangent is positive in quadrant 3. So sine is going to be automatically negative. So this is going to be negative. So some people find this easier to help them memorize if it's going to be positive or negative. But I have another way. Where does 244 degrees fall? Just draw it. Isn't 244, 90, 180? Oh, this is 270. I'm a little bit short. Is sine x or y? If sine is y, that's a negative y value right there. How about cosine? Are we on the left or the right side of the graph? We're on the left. Cosine is also negative. Okay. All right. So the idea here is if I can find the reference angle of an angle, any angle, and if that angle, that special reference angle turns out to be a special triangle, I can actually find the sine, cosine, tangent without doing much work. So here's our next triangle that we're going to do right now. It's going to be a 60-degree triangle. Okay, that's our reference. So for 60-degree triangles, also 60-degree can be known as pi over 3. Pi over 3. Back here, 30-degree triangles are 30 degrees is pi over 6. Okay, 30 degrees and pi over 6 are synonymous with each other, just speaking different language. Okay, so pi over 3, here we go. 60 degrees. Have we seen a 30-60-90 triangle before? Yes, we have. The sides are, short side is 1, 2, square root of 3. If I see this, I know the sine of 60 degrees is opposite over hypotenuse, which is 2. My cosine of 60 is adjacent. That's 1 over 2. My tangent of 60 degrees is square root of 3 over 1. No calculator needed. If you want to check on a calculator right now, let me go ahead and show you guys. That would a calculator give us the same answers here? Oops. Stupid commercial. Okay, so we're gonna, Curtis, what's up?
How did you know that the reference angle is 60?
Okay, so coming back here, so if I said 300 degrees going all the way around, right? But
Yeah.
isn't a full circle 360?
Yeah.
So that's what I needed left
Okay.
to get back to horizontal.
Nice.
Looking at another angle over here, this was 120. How much left do I need to get to 180? 60. So the reference angle is always the angle that brings you back to 0. Oh, back to the horizontal. Whether it's 180, 0, or 360.
Okay. Thank you.
Yep. Anyone else with any questions, please? Okay, let me try to finish this up. Okay, 45, 45, 90. If I'm asked to find the sine of 135, first step, draw across. Now, where does 135 go? Something over here, because it's bigger than 90. Draw the triangle. Now, what would your reference angle be here? To get from 135 to 180, it turns out that's a 45-degree angle. Hey, 45 degrees is a special triangle for me. 1, 1, square root of 2. Are any of these going to be negative? Yes, because we went left. Last step, since we have all 3 sides of our triangle, just copy the sides. Sine is equal to opposite over hypotenuse. Opposite of this triangle is 1 over square root of 2 hypotenuse, which is square root of 2 over 2. Done. First step, draw the cross. Second step, draw the triangle. Third step, fill out the sides of that triangle, check for negatives. And fourth step, just copy the values back in because you now have all the sides.